In the last chapter, we saw that nuclear energy has the potential for solving the world's energy problems, provided we can either figure out an answer to the problem of long-term storage or disposal of highly radioactive waste, and/or until we can figure out and develop the technology to build fusion reactors. However, as we also noted in the chapters prior to that, our supply of petroleum is running out in 30 to 40 years. We may not have the time to wait for those nuclear technologies to develop before we need to find some alternative source of energy. Which brings us to this chapter, which is alternative energy sources. This slide shows the major renewable, sustainable energy sources currently being used in the United States. You'll note that they are comprised of biomass energy, hydropower, wind energy, solar energy, and geothermal. Biomass energy is simply the burning of wood, any non-fossil fuel material. It still comprises the largest amount of non-fossil fuel or nuclear energy sources. Second to biomass is hydropower. This is the electricity primarily that's generated as a result of hydroelectric dams. Wind power is generated through windmills. Solar power is generated from solar cells. And geothermal power is generated based on the actions of the earth itself. However, all of these renewable energy sources only make up about 6.7% of the total U.S. energy use in 2007. Unless we can significantly increase the number of and amount of energy being produced by these renewable energy sources, we're going to fall far short of the amount of energy that we're going to need when we run out of our known petroleum reserves. One of the most important and potentially sustainable technologies for generating energy is solar power. And as you'll see when you read the textbook, there are a number of different devices, technologies that have been developed in order to help harness solar power. Some of them are fairly straightforward. They take the light of the sun and they concentrate it in apparatus similar to this solar trough collector, as it's called, and using the heat of the sun's rays, you can heat up water or some other liquid that flows through these pipes, and those pipes, when that liquid is heated up, will allow for the circulation of this heated water through other devices such as turbo generators, and hence the development of electricity through a passive system of capturing sunlight. Perhaps an even more promising technology for capturing the sun's energy is through the use of a device called a photovoltaic cell. You see a picture of one right here. Photovoltaic cells, or PV cells, are able to directly capture energy from the sun and convert it into an electrical signal that can then be used to power a motor or any other device that depends upon electricity. Photovoltaic cells are particularly useful for devices that require small amounts of energy. For instance, many of you probably have calculators that are powered by a photovoltaic cell, or perhaps a watch that's powered by a photovoltaic cell, or even cell phones in some cases. Devices that require relatively low amounts of electrical energy are particularly well suited to photovoltaic cells. Furthermore, the development cost for PV cells has significantly come down in the last 20 or 30 years, such that they can be made relatively inexpensively now. On the same hand, the application of PV cells for developing large solar, what we call solar farms, to capture the sun's energy and convert it in large scale to electrical energy is becoming more and more popular. In fact, right here in Chicago, we have a large-scale urban solar farm not far from the university. at about 120th and Halsted, if you care to take a look at that someday. And these are large panels of photovoltaic cells that focus on the sun and follow it throughout the sky during the day, harvesting its electricity. I predict in the future that there will be many more of these solar cell farms, not just in the desert Southwest where there's a lot of sun, but even as is being demonstrated here in Chicago now in urban areas. Another very significant source of renewable energy is wind energy. And wind energy is probably the fastest growing form of renewable energy development in the world right now. Even here in Illinois, a number of wind farms have sprung up. If you drive south along I-55 as you get towards Bloomington, you'll note on the south side of the road a relatively large wind farm which consists of these windmills that you hear, or actually wind turbines is a more technical term, that have sprouted up in the farmlands just north of ISU. There's also two particularly large wind turbines on I-94 just north of Milwaukee if you want to look at those. Obviously, wind turbines depend upon wind in order to generate electricity, so placement of wind turbines has to be carefully considered in order to make them economically viable. The best locations usually being, on mountains or relatively high altitude areas and or offshore. I know that not long ago there was a proposal to even place some of these wind turbines off Lake Michigan, off of Evanston. However, due to objections of neighbors, that never really happened. Probably one of the more ingenious forms of generating energy is geothermal energy. The basic concept with geothermal energy is to sink a pipe, at least on an industrial basis, to sink a pipe far down into the Earth's crust until you get to a point where the rock that the pipe is in is actually hot because of the Earth's core being hot. You then take water and you shoot the water down the pipe. You let the Earth itself heat the water up to boiling and then bring that boiled water, which is now steam, back up through another pipe and use that steam to drive a turbo generator, the same way we used steam produced by either coal-fired power plants or nuclear-fired power plants to generate electricity. There are, in fact, some geothermal energy applications right here in the Chicago area. Walgreens Pharmacy in Oak Park, in fact, is operated through a geothermal well. On a more personal basis, it's possible to utilize the principles of geothermal energy even in an individual home, simply by taking and creating a system of pipes buried in the ground below the freeze line, usually a little more than 6 feet. And what happens here is that in the summer when it's hot out, you can pipe water or some other fluid down into the ground, and because 6 feet or more under the ground, the earth is much colder or cooler than the air above it. The water that flows through these pipes will be cooled off by exchanging the heat in the water with the cool of the earth, and by the time the water circulates through all these coils and comes back to the house, it will cool down to the point where it can be run through a series of pipes like radiators and be used for cooling down the house. Or alternatively, in the winter, you can take the same fluid and circulate it down below the ground where the ground is actually warmer than the upper air. And so when the cold air from the house or cold liquid that's absorbed from the house passes through these coils, it is actually warmed up by the earth so that when the liquid passes back into the house, it can help to heat the house through, say, a radiator system. So there are a number of interesting renewable energy sources being looked at and considered for industrial and commercial development. Which ones win out and become more popular, just like the old 8 tracks versus cassettes, and like the old VCR versus beta. Whichever one is most competitive, whichever one is easiest and cheapest, is the one that most likely will occupy or fulfill our future energy needs. But what's not in doubt is that we will need some type of energy supply, one that's renewable and sustainable far beyond the known petroleum supplies that we have, and hopefully well until such point as we can develop viable nuclear technologies.